Okay, everyone, this is our last new unit, and it is volume of pyramids and cones. So part of the situation here might involve Pythagorean theorem. We kind of previewed that in our previous video. And the reason why, I'm actually going to skip the warm-up and come back to it for a second, is that a cone is actually like a cylinder, but it's actually a fraction of it. It's a third of a cylinder, the same way that a pyramid will always be a third of a prism, on the prism being whatever shape its base is. So generically, this formula here works for pyramids and cones of any kind because B, capital B, stands for the area of the base. So if you do the area of the base times the height and then multiply that by 1/3, you will find the volume for any cone or any pyramid, but we're going to focus exclusively on square pyramid. Now, this picture to the left, oblique pyramid, that just means if it's slanted, you still need the regular height. That's what you'd use in the formula for volume. And the reason that's important is sometimes you're given what's called the slant height. So this 10 right here is actually called the slant height, and we don't need that when we find volume. We need the actual height. We want to know how tall an object is, not how tall it is on a diagonal or on a slant. So if you're given a slant height like you are in this picture, you have to use Pythagorean theorem to figure out the actual height. So what happens in these problems? If it's a pyramid or cone, you're given slant height. What you'll notice here is, first of all, slant height is like the hypotenuse of a right triangle. The height then would be like one of the legs, A or B, in the Pythagorean theorem. And then here's the trick. This whole length of the pyramid is 12 inches, but when you do a triangle of it, it's half that length. So you want to make sure that if you have to use Pythagorean theorem, that you only use half of this length right here. So I've designed a triangle over here that matches that one, and you can see that it has a base of 6, the triangle, and a hypotenuse of 10. And then, excuse me, we do Pythagorean theorem. So remember, a squared plus b squared, where these are a and b, equals c squared, and c is your hypotenuse. So by doing that work, we can find the actual height, and it ends up being 8. So you can kind of follow the work there. If you need to pause to write it down, you may. But you're going to do that throughout the notes here. And the only reason you'd ever have to is if you need the actual height when you are finding volume. So some of these are straightforward. You are given what you need. Other ones you have to find the height. But instead of just writing this generic formula with a capital B, I've decided to tell you how to do them a little bit more specifically. So in general, that would be what capital B is, but since it's a square, the area of a square is always one of its sides squared. Therefore, that's the formula for volume of a square pyramid. In the same way that in a cone, it's always 1/3 times the area of the base shape, which is a circle. That's why it's pi r squared. So let's take a look at our examples. So over here, this one was, everything was given. This is a square pyramid. One of its side lengths is 5. That's why I wrote S equals 5. Similarly, they gave you the height. They gave you the actual vertical perpendicular to the base height, not the slant height. So we just plugged them in. 1/3 times the side length of the base squared times the height, and there's your answer. And remember, if you're not told any units, you just write units cubed or U cubed, and that's it. Now, the second one involved a little work. Now, here's a cone, and if you look here, similar to the warm-up, in a cone, you can think of this as a radius or a diameter. So in the warm-up, I gave you like the whole distance across a pyramid. That would almost be like a diameter. But in this case, they gave you the radius, and they gave you the slant height. So really all we need to do is Pythagorean theorem first to figure out what this length I just highlighted is. We want to find the height. So what you see here is a continuation of that. There's the Pythagorean theorem work. And for the height, you end up with 10.97. So again, if you need a moment to pause, you can. Now we know the height is 10.97. I don't need the slant height anymore because for volume, you would just do 1/3 pi r squared times height. And you could either write your answer in terms of pi or as a decimal. Either one. And again, if you round a little early, like if you didn't write 10.97, you kept that answer throughout your calculator, or if you rounded early with 1/3, all these answers just have to be in the ballpark. As long as you show your work, you're going to be fine. Okay, now the third one here is just like number 2, but with a pyramid. So again, be careful. This 40 length is not the length of this triangle. The base of that triangle is half that length. That's why there's a 20 right there. So that's something to be careful of when you do these problems. Got to do Pythagorean theorem because we need capital H. So we do Pythagorean theorem to the side here, and we come up with an answer of 15 feet. And then to find the actual volume, you would do step 2. So I'm going to zoom out a little bit so you can see that. So again, the first thing we did, that's everything right here, is we found the actual height of the pyramid to be 15 feet. And then we plugged that information in here to get an answer of 8,000 feet cubed. Okay, we only have one more example, and it is sort of like a compound shape. So you'll see this in the homework as well, where they'll attach 2 shapes. So in this case, you have a cube and a square pyramid below it. So anytime you have compound shapes, you basically have to find the volume of each individually and then add them up. What's going on here? You're told this is a cube with length of 5 feet. So that's this length right here. It's every length really, but we're talking about the height here because it tells you the entire bin is 9 feet tall. So basically what I've already kind of done for you here, this height here had to be 4 feet because 4 plus 5 had to come out to a total of 9. So now you know you're working with a cube with all dimensions being 5, and that's like a prism. That's like our previous notes. The volume of a cube or a square prism would be length times width times height, which are all 5. So this is where the term cubing comes from, because this is the same as 5 cubed, or 5 to the 3rd power, and that's 125 for the cube. For the square pyramid, if I drew that over here maybe separately, you could see that you have 4 for the height, so that goes right here, and then these lengths are all 5. So if it's a square base, that's like saying 5 times 5, you'd have a 1/3 in front of it, and then times that height of 4, which you see right here. So again, 1/3 times 5 squared times the height of 4 gives you 33.33 cubic feet. And then, like I said, anytime you have a compound shape like this, in the end, you're going to sum them together and add and get a total volume, in this case of 158.33. All right, everybody, that's it. So again, volume, pretty straightforward. Again, the only difference here with these notes as opposed to last time is there's a 1/3 in front, but it is just like cylinders and prisms, just with a little bit of added work with that 1/3 in front. Okay, that should help you with